Hi everyone, this is the introduction video for CS6340 Delta Lab. The corresponding lecture for this lab is Lesson 10 on Delta debugging, and you're going to be implementing the algorithm presented in the lecture, so if you haven't already watched that, I would highly recommend doing so before you attempt starting the lab. The goal of the lab is to implement the Delta debugging algorithm to find a one minimal failing test case, and in the first part of the lab, you're going to be using line granularity, so you'll be minimizing the failing test file down to the line that's causing the program to crash. And then in part 2, you're going to be expanding your algorithm to use character granularity, so you'll take the failing line and then further minimize that down to the character that's causing the program to crash. The resource section of your lab instructions has one link that you can use to learn more about Delta debugging. Another very helpful resource will be your lecture notes. This slide from the lecture outlines the steps of the minimization algorithm that you're going to need to implement, so I would highly recommend working through a couple examples by hand before you even start coding to make sure that you understand what's going on, and then you can go step by step through this slide and implement each section in code. The setup for this lab is pretty straightforward. It's a later lab, so I'm not going to go into details on how to download this from Canvas, but you'll need to get the Delta zip from Canvas and then copy it to your home directory and unzip it. Once you unzip it, then there'll be a couple of Java files that you need to compile, and then you're ready to get started. So let's take a look at what this looks like on the VM. Okay, I've already copied the zip file to the home directory, so let's go ahead and unzip that. As you can see, it creates a Delta directory with 6 files inside. So looking at those, we have Delta debug, which is the skeleton file that you're going to be implementing your algorithm in. Delta debug test.java, which is the test class that you're going to be using to run your changes in Delta debug. Secret coder, which is the buggy encoder program that we're going to be minimizing the input for. Long failing text, which is the input file that makes secret coder crash. And then 2 files for the part 1 and part 2 that are the correct minimal test input that you'll be comparing your output against to make sure it's correct. So now let's go ahead and compile our Java files to get ready to run the lab. You can either do these as a single command or do them all in one command and compile them at one time. So this will be the Java C command that's listed in your lab instructions. And once that is completed, then you're ready to go. So as I mentioned before, Secret Coder is the buggy program that we're going to be using for our testing. Secret Coder implements a Caesar or shift cipher with a right shift of 98 places. Instead of the regular alphabet, which ciphers are normally implemented on, this program is intended to encode the 128 characters in the ASCII character set, which have the decimal value of 0 to 127. So to run this on your VM after you've compiled in the earlier step, you just need to do Java secret coder and then whatever input file. So let's take a look at this on the VM. So for the purposes of this demo, I've created a sample.txt that just says this is a test. So we're going to try to run secret coder on this by using the command java secret coder sample.txt. So as you can see, this came back with no errors reported, and it created the output.txt file that's expected. So looking at this file, we can see it has some characters that have been encoded from the original message. So now let's try to run it on our long failing text.txt file and see what we get. So here we get array index out of bounds exception, and this is what's expected when the input file has a non-ASCII character. So for your Delta debugging algorithm, this is the error that you're going to be looking for and minimizing it down to the minimum failing input that contains one of these characters. So for part 1, it'll be the line with the non-ASCII character, and for part 2, you'll be minimizing it completely down to the non-ASCII character itself. So you'll be implementing the Delta debug method in Delta debug Java for part 1 and using the line granularity, as I've said before. You'll test your changes by running Java Delta debug test and then with the argument line, and this will send all of the parameters to Delta debug method in the same way that we're going to be sending for grading. So it's extremely important that you don't make any changes to the type or method signature of Delta debug in Delta debug.java. Otherwise, your program is not going to run correctly in grading, and you're not going to be able to get the points that you deserve for the effort that you put into the project. There are a couple other helper methods in Delta debug You can modify or add any other new ones that you want to. This is totally fine. The only thing you're restricted from is editing what's going into the delta debug method. And then finally, once your algorithm is implemented, you're going to use the diff command to compare your output with the provided minimum failing test for the line. So taking a look at the delta debug Java file, we have at the top the delta debug method. It's currently a public void type with 5 different parameters. So this is what we're stressing. Do not modify any of this. The auto grader is going to call your delta debug method, and it's expecting it to be exactly like this, so it'll cause issues and you won't get credit if yours is different. So looking at the parameters, the first one is char granularity, and this determines if you need to minimize the failing input file down to the character or line level. It'll be true for part 2, where you need to do it to the character, otherwise for line it'll just be false. The second one is the program, and this is the command that you're going to be using to run your program. The third one is the failing file that causes the program under test to crash. The fourth one is the error message that you're looking for, so in this case it'll be the array out of bounds exception. And then the last one is the final minimize file, which is what you're writing your minimize output to at the end of your algorithm to compare against the provided one to see if your answer is correct. So it's important for the sake of grading to make sure that you're using these parameters and you don't hard code any of this stuff in case like the file locations are a little bit different on the grader. We'll be passing that in as we expected. So if you've hard coded something, it might cause the grader to crash and then you won't get credit there. So scrolling down a little further in the program, we see a couple of helper methods. It's totally up to you if you want to use these or not. If they help you, great. If not, that's fine. You don't have to use them. The first one is for reading a file in. The second one writes to a file. And then the third one helps run your program. So feel free to modify these in any way that you need to. The types don't have to stay the same. The parameters don't have to stay the same. These are just to help you. And you can also add any more that you want to. Okay, so taking a quick look at the delta debug test file, you'll see that you can either run this with the line option or char option for part 1 and part 2. They call delta debug in the same way, just 2 of the parameters are different, and that's the first one for char granularity, and then the last one for the output file, just to help you keep those apart. None of your logic should be in this file because you're not going to be turning it in. The only thing that you will want to change, most likely, is the third parameter, which is your input file, if you want to test your algorithm on different kinds of input. So part 2 expands on your algorithm from part 1 and minimizes down to the character level instead of just the line. So instead of ending your algorithm after you've minimized down to the failing line, you're now going to take that line and minimize it down to the failing character. So you run this in almost the same way, just instead of Java delta debug test line, you're now going to have char instead. And then once you're finished, instead of comparing against the file that has the underscore line at the end, you're now going to compare against the one that has underscore char. So there's a couple considerations for grading. First, your algorithm needs to run in less than 5 minutes on the course VM to get credit. This should be more than enough time. Mine runs in about 30 seconds, so I think 5 minutes leaves you plenty of leeway. And this is also by test case. So for example, if your algorithm works and completes in less than 5 minutes for the line granularity, then you'll get credit for that. But if for some reason the character granularity doesn't complete, then you just won't get credit for that part. So part 1 and part 2 are each worth 50% of the final grade. 20% of each 50 is for correctly minimizing the long failing text that we provide. So you'll be able to double check yourself on this part by doing the diff command. And then the other 30% of that is for hidden input files. And this will be very similar, but it could have a different file name, different number of lines, different failing character, different position for the failing character, or other changes appropriate for a text file. So for this submission, you'll want to follow the information in the items to submit section. The only file you'll be turning in is your delta debug Java file. No other files. Make sure you're turning in the Java file, not the compiled version. You'll need to zip this into lab7.zip. And the best thing that you can do is to run the zip validator Python file that's provided And the command is here and also in your lab document for you to copy over to your VM. And this should tell you if you've zipped everything up correctly or not. So good luck, and I hope you enjoy this lab. If you have any questions, feel free to post on Piazza or come to one of our office hours on Slack, and we'll be happy to help you.